question 1.1. We are performing a manual recursive DNS lookup for www.example.com. Normally DNS stands for domain name system. It is essentially internet's phone book. It translates human readable domain names like www.example.com into an IP address that computers use to communicate. So this resolution happens automatically behind the scenes. In this demonstration, we will manually walk through each step of this resolution process to understand how exactly DNS works. The resolution that we show follows a hierarchical chain. First, we ask the root DNS server, which is at the top of the DNS hierarchy. The root DNS server refers us to the TLD server for the .com. The TLD server refers us to the authoritative name server for example.com, and then the authoritative name server gives us the final IP address. We are required to start from the root, like the name server a.rootservers.net, follow along the chain and using the dict command. So let's go ahead. The first step is to find the IP address of the root name server, that is a.rootservers.net. We use dict command, which is a DNS lookup tool available on DNS. So let's start. Root servers net. Let me walk you through the output section. The OP code query. This is a standard DNS query. Later the status shows no error, which was successful. The ID here is 19673. This is a unique transaction ID that is required to match with each query and its response. Later the flags are QR, RD, RA. These three flags are set here. QR means this packet is a response, not a query. RD means its recursion was denied and our client asked for a recursive lookup. RA means recursion is available. This server supports recursive lookups. Query 1, like we asked one question, we got an answer back, but there are no authority records, and one additional record is the OPT record for the eDNS. The pseudo answer section, the question section shows that we asked give me a record, meaning IPv4 address for a.rootservers.net. In the internet class. The answer section shows the results that a.rootservers.net, the domain we queried, gave like 3754, the TTL meaning the time to live in seconds in this record, which can be cached for like the internet class. A is the IPv4 address record, and 198.41.0.4 is the actual IP address of the root server. So the root name servers is a.rootservers.net. Now I'll query the root server directly at the IP in 198.41.0.4. I'll use 198.44 to specify which server to query directly. I also use plus non-recurse to tell the server not to do recursive lookups. We only want the referrals, so only we can follow the manual chain. So let's do that. No recurse at rate 198.41.0.4 www.example.com. Here you go. Let me walk you through the output. Just one sec. As we see the OP code, the header section shows status no error. Flags QR. Notice this time only QR flag is set. There is no RA, which is the root server does not support any recursion. The root servers are designed only to give referrals and not to do the recursive lookups. Warning. Yeah, the warning recursion is requested but not available. This confers that root server doesn't do recursion. Just one sec. Yeah. The answer is 0. Sorry, the answer is 0. The root server has no direct answer for www.example.com. Authority is 13. It is referring to the different .com, the TLD name servers. Additional is 27. 27 additional records is like providing the IP address for those name servers. The authority section shows 13 NS records, name server records, all pointing to different .coms, the TLD servers like gtld servers.net, and so on. The TTL is 172.800, which is approximately like 2-3 days. Additional section also provides us the IP addresses of those TLD servers as a glue records. This is helpful because it saves us from having another lookup to find their IPs. For example, a.gtldservers.net has an IP of as you see 192.5.6.30. Now I'll query the TLD server at 192.5.6.30 to find out who is responsible for example.com. So let's do that. Take plus no recurs add rate 192.5.6.30 www.example.com. So let me quickly walk you through this output. The error section status no error. The error section shows that there is no error, which means successful. The QR flag again, only the QR flag, no RA. The TLD servers does not do only recursion, they only give reference. Answer is 0. The TLD server does not have the final answer. Authority 2, it is referring to the authority name servers, for example, .com. Additional is 13, that is 13 additional records with this IP address. The authority section now shows the two name server records. One is HeraCloudflare.com and EloitNS Cloudflare.com. These are the Cloudflare name servers, meaning example.com uses Cloudflare for its DNS hosting. The TTL again is 172.800, which is approximately 2 to 3 days. The additional section also provides us multiple IP addresses for each cloud name server, both IPv4 A records and IPv6 portable A records. Here, Hera NS, Hera NS Cloudflare.com, we have 3 IPv4 addresses: 108, 162, 192, 162, 172, 64, and 173. We will use the IP at 108.162.192.162 again for the final step. So finally I'll query the authoritative name server. Dig no recurs add rate 108.162.192.162 www.example.com. So yeah, let me quickly walk you through the output. The header section again shows status no error. QR flags, there are 2 flags this time. QR means there's a response, AA means this is the authoritative server. This is a very important flag, meaning this server is officially the authoritative server source for the example.com, unlike the previous responses which were referrals, and this is a definitive answer. Authority, later the answer is 2. We finally got our 2 answers. Authority is equal to 0, no further referrals needed. The answer section shows that example.com has 2 IP addresses: 172.66.147.2.3 and 104.20.23.154. The TTL is 300 seconds, which is like approximately 4 to 5 minutes, meaning this records refreshes frequently. The AA flag confirms that this is an authoritative answer from an official name server, for example.com. And we can conclude that our DNS lookup is now complete. To summarize the complete DNS resolution chain for example.com, step 1 the root servers, second the GTLD servers, third the Cloudflare servers. This is exactly how the DNS resolution works behind the scenes every time you visit a website. Your computer follows the same chain automatically in milliseconds. The key difference is that a recursive resolver does not do all these steps for you. In demonstration, we did each step manually to follow the process and understand it. So I can conclude that question 1.1 is successfully completed, and thank you so much.